So far, we have two ways to prove that something is a parallelogram. We can prove that the sides are parallel, which is the definition. And we have also proven that if the opposite sides are equal to each other, then that is enough to prove congruent. What we are going to prove now is that if you have one set of sides are parallel and congruent, we're going to prove that it's a parallelogram. Now, we actually did a quiz on this one, and it showed up in one of your previous guides. So that is, you're going to look at worksheet B for that one, okay? Worksheet B and also worksheet A will help you with that guide. This one, on the other hand, we have never done before. And so, again, the significance of this one, I'm going to let you look other things up. I don't have to do the same thing again for you. But this one is that if this is all you know, that you actually would know that it is a parallelogram, which is kind of cool, because that means that if I go like 4 long and 4 long, as long as they were parallel and congruent to each other, I know that my shape actually is going to be a parallelogram. So we have one last guide to prove that it is a parallelogram, and that is if all I know is the diagonals bisecting each other, that it is a parallelogram. So if I'm talking about the diagonals bisecting each other, plural, I need to draw in diagonals, plural. And we need to look for what triangles will help us. So if I want to talk about the diagonals bisecting each other, I want to talk about this being equal to this and this being equal to this. So the triangles, if I choose like this big triangle, that's not going to help at all, because then I don't know anything about the parts of this, and this isn't equal to something else. But if I choose like these guys, then I can say that those and those are equal, and that'll be helpful. Or if I choose the white ones, then I can say that these and these are equal, and that will be helpful. So it doesn't matter. I picked the shaded ones, so that's what I'm going to do. We are starting with the fact that the diagonals bisect each other. So we're finding out if this just tiny little fact is enough to actually prove this is a parallelogram. There's not many proofs like these because there's not many things that if you just have one tiny little fact, it's enough other than the definition. But these work, so we're going to do them. So this is our given, which means that specifically AE equals EC and that DE is equal to EB. Now, I have forgotten something. I need to say that I draw AC and BD and label E. And then that is where those guys come from. And that is my definition of bisect. So I'm going to mark them. And it should be pretty clear. What else? We can't get these sides, but we can get these angles. Hopefully you recognize them. I'm going to put, no, I won't. I'll write them. What, AED and BEC. And that is vertical angles are equal to each other. So I've got congruent triangles. So let's state that and then see where that takes us. A goes with C and D goes with B. And my reason is SAS. So I still need that it's a parallelogram. So I do have some options. I have a lot of options. I can show these angles and these angles, and that will give me, the same two parallel lines. Let's go ahead and show that. If I get these and these, I will get those. And then I don't want to make it too dark because we're not going to use them. If I use this one and this one, I still get the same exact parallel lines. So that isn't very helpful to use the definition. I've already proven that opposite sides are equal will be enough to prove it's a parallelogram. So I can use these and these, but then I don't want to have to prove these two triangles are congruent to each other. So this little powerhouse right here that I've just proven, I can use. So if I can say that these guys are parallel and congruent, then I'll know that it's a parallelogram. So let's go ahead and do that. We obviously can say that they're equal because those are congruent parts. And I'm going to go ahead and put numbers in here. I can only get angles, people. I cannot get parallel lines from congruent triangles. Congruent triangles don't give me parallel things, they give me equal things. So I have my angles equal, but those particular angles I chose very carefully because those give me parallel lines. So it's just 2 steps, but don't skip them because then you're just making up stuff that isn't true. And we would need to say then that my alternate interior angles, that are these guys, since they're equal to each other, that is what gives me my parallel lines. And these 2 facts together say that it is a parallelogram. And that is, we'll go ahead and just draw a picture, that if I can prove congruent and parallel, that gives me a parallelogram.